In this video, we'll get a better understanding of the different types of cameras and their uses in Unity. In some regards, a 3D camera can be viewed conceptually like a real camera. To set up your shot, you need to position the camera properly and rotate it so it's pointing at what you want to see. But the differences really stop there. With the traditional lens camera, light passes through the lens, projected onto a flat piece of photosensitive film or CCDs. You can focus the lens for different depth of field effects. You can also change out the lens for different effects like telephoto, wide angle, fisheye, and so forth. In a game engine, the camera really is just a projection of the 3D geometry onto a 2D plane of the display. You can simulate lens effects like focus, lens flare, and fisheye, but they are processor intensive to do so. There's two different types of 3D projections you can create within your game: perspective and orthographic. The perspective projection is most like a real camera, or really how we see the world. This is most commonly used in first-person and third-person games. Objects that are closer to the camera are larger than the same size objects that are farther away from the camera. Orthographic projections do not really exist in the real world. The computer maintains the same relative size of the object no matter how close or how far away it is from the camera. Common uses of orthographic cameras include top-down or isometric views on games. The view frustum determines what is rendered in the display. The perspective camera has a pyramid view frustum with a narrow field of view close to the camera and a wider field of view farther away from the camera. As an object moves closer to the camera, it'll appear larger or closer. The camera renders everything between the near clipping plane and the far clipping plane. If objects move closer than the near clipping plane, they are not rendered. If objects move farther away than the far clipping plane, similarly, they're not rendered. The orthographic camera has a rectangular view frustum with a constant field of view or orthographic size throughout. Objects, no matter where they are in front of the camera, will appear the same size relative to other objects. The same concepts apply in terms of near and far clipping planes with the orthographic cameras as they do with the perspective camera. Our objectives in our project for this video are to understand some of the camera settings, make the perspective camera controllable, and add a mini-map through the use of a second orthographic camera. So the first thing I want to do is just play around with my main camera a little bit to further demonstrate some of the concepts we just spoke about. So let me click on my main camera. It is a perspective camera, a perspective projection. And actually, as we look out in our scene, you can actually see that view frustum sort of visually represented there. As I'm playing with things like field of view here, the default is 60. Let me just make that wider. You can see how it's affecting the game world. Is kind of simulating like a fisheye sort of view. And then if I go the other direction, it's like it's zooming in, but really it's not moving the camera. It's just changing the field of view, changing that sort of projection. So we'll go back to 60, which is the default. The other thing to look at is the clipping plane. So the clipping plane is actually set here. Basically, this is saying at 0.3 meters, things will no longer be rendered, and at 1,000 meters, things will go off the far clipping plane. 1,000 is pretty far. If I bring this back, let's say to something like 4, you can see that the clipping plane is just beyond the Earth now. And if I actually play this, just beyond the sun, I believe the Earth will actually disappear. You can see it disappear there, and then it will reappear on the other side. So that's going, sort of out of the far clipping plane. And depending on the location of my camera, if it's too close, the object may come on the inside of the near clipping plane and then essentially kind of cut through the camera. And I'm sure everyone has seen that in games today. So 4 is probably too small. Let me go ahead and set this at something like 20 meters. So everything will be likely rendered in my display here. But that's something that you can always adjust to optimize your project If it's rendering too big of a view frustum with objects way out in the distance, it may affect performance. So by making that a little bit tighter, things will play back better depending on the platform that we're playing on. So really, we didn't really change much there. I just wanted to kind of show some of those concepts related to the perspective projection, the field of view, in the near and far clipping plane. So the next thing I want to do is actually create another camera in my world. So I'm going to go ahead and go up to Game Object and create a camera. And this camera just got created, kind of out in my world. You can see that my game view actually changed because it sort of switched to that new camera that was just created, which is fine for purposes of example. My camera isn't really where I want to have it. So one thing I could do is actually go to this main camera and see where that is. And under Game Object, I can select Align View to Selected. So what that's going to do is align my scene view to the selected game object, which in this case is the camera. So this will show, in essence, what we were seeing out of the main camera previous. So now that we have that, let me go to the new camera and select it, and then go to Game Object, Align with View. So this is going to move the game object to be aligned with the view. So in essence, it's going to put this camera really right on top of the previous camera, so they're both really right on top of the same spot. And let me go ahead and rename this camera to I'm going to call it my mini map camera, because I'm going to use this camera to create a mini map. And let's go ahead and look at some of the properties here. The first thing is it also has an audio listener, and really you can only have one audio listener turned on at a time in Unity. And if you have multiple, it will throw a warning message, and Unity will sort of pick one of those audio listeners, which may not be the one you want. So I'm going to go ahead and turn off this audio listener. I could even just remove the audio listener component, but I'll just turn it off. That's fine. The other thing I want to do is change the projection. So rather than the perspective, let's go and pick orthographic. And the orthographic projection, you can see my game view just changed. If I play, for purposes of example, you can see if I go in a top-down view over here, let me move to the sun by hitting F. But you can see the Earth is, of course, rotating around the sun, and the moon rotating around it. But down here in the game view, since it's orthographic, the size of the Earth and the size of the moon do not change as it's moving around the sun. So that's the big difference. The same relative size of the objects is maintained consistent with the orthographic projection. So let me go back to the mini map here. And really what I want to do is I don't want to have the same projection, or the same view as the main camera. I actually want to have a top-down view on my world. So, over here in my scene, I've been, somewhat placing, I'm in the top view. I can switch, in and out of it, and I can zoom in and zoom out to kind of get the orientation that I want. I've got my mini-map camera selected, and once again, under Game Object, I can say Align with View. And now, if I press play, you can see I've got a top-down view on my game world. The Earth is rotating around the sun there. So that's what I wanted. But in reality, I want to have both of my cameras playing at the same time. And in fact, they're just sort of layered on top of each other right now, so I'm not really seeing the main camera because the minimap camera is overlaying that. And that's really set here as the depth. So my depth of this camera is 0. If I go back to the main camera, it's -1. So if I change this, and let's make this a depth of 1, you can see now it just switched back to the perspective camera, because the higher the depth number, that's what's going to be rendered on top. But we can leave this at -1. And go back to the mini-map camera, which is the depth of 0, because really we want these both to be rendered at the same time. So the way I'm going to do that is I'm going to modify this view rect property. So right now the width and the height is 1, which is 100% of the screen. I'm going to change this to 0.25, and 0.25. And you can see down in the corner now of my game view, I can see that mini-map camera, and and then the main area is the main camera. So if I press play now, everything is essentially rendered. But it looks a little funny because I've got the skybox down here, or it doesn't look funny, it just is hard to see. So let me modify one other property. So you can see where it says clear flags here and it says skybox. That's basically saying it's going to render the skybox. Let me switch this to solid color, and now it's on a blue background, and I could change that color, of course, by clicking the background and make it whatever color I want. I'll keep it as kind of a dark blue. And now when I press play, we can see the sun, and we can see the Earth rotating. It's a little bit hard to see the Earth. Part of that is the size of my projection maybe is a little bit high. In essence, it's kind of like being zoomed out. So let me change the size, make it a little bit smaller, maybe make it 3, and hit play again. And now it's a little bit easier to see the sun and the moon and the Earth. The last thing that I want to do is I want to make my camera controllable. Not the mini-map camera, but actually the main camera. In essence, what I want to be able to do is I want to be able to click on the various planetary bodies, the game objects, and have the camera look at them. So of course we could do this with scripting. Anything that's interactive, we often do with scripting. And we've got two scripts to do this. We've got a change look at and a look at target. So the look at target is a script that's meant to be placed on the main camera. So let me go ahead and drag and drop that onto the main camera. So now it has the look at target script or component attached to the main camera. And the change look at target is the script that we place on all the game objects that we want to be able to click on. So what this does is it essentially responds to a mouse event, a mouse down event on the game object, and resets the target of that other script. So let's go ahead and put the change look at script on the sun, put it on the Earth, and even put it on the moon. Okay, so if I go back and look at each of those game objects, it should now have that change look at target script or component attached. So if I go ahead and play again, if I click on the Earth, now the main camera, if I zoom out here a little bit and select the main camera, you can see the main camera is stationary, but it's rotating, so it's constantly looking at whichever game objects I've last clicked on. So if I click on the sun as it comes by here, now I'm looking at the sun. It might be a little bit hard to do, but I can even click on the moon as it comes by here and gets a little bit bigger. There's the Earth, and there's the moon. So now I'm targeting the moon as it's coming around. And since I've got two cameras, I could even click on the mini-map. So if I click on the sun on the mini-map, that's a quick way to kind of reset that main camera to be targeting on the sun once again. And I can click on the Earth. It's probably a little hard to click on the moon since it's so small within the mini-map. So anyways, we've played a little bit with the perspective camera. We've added an orthographic camera and essentially made that our mini-map. And we've made the main camera controllable. In the next video, we'll discuss how to build and deploy our Unity projects.